Next in line, we have Mr. Karthik Suresh, who is joining us from Catchpoint. He's a technical leader with over 7 years of experience who started his career as a developer. He's currently managing professional services team at Catchpoint and helping customers worldwide to improve user experience of the digital platforms. He's going to share his deep insights on how SREs can effectively adopt, monitor, and automate backup for CDNs. Ladies and gentlemen, let's all welcome Mr. Karthik Suresh.
Hi everyone, I'm Karthik and I'm very excited to be part of the DevOps India Summit 2021. I think this has been an amazing opportunity for various members and participants to share and learn new technology, tools, and processes. So I'm happy to be a part of this summit this year and looking forward for some great sessions. For the next few minutes, I'm going to be discussing about content delivery network, or more specifically about effectively implementing content delivery network based on monitoring data. So without further ado, let's move into our session. All right, so I think most of you might already be familiar with the content delivery network or CDNs, but for anybody who is not familiar, we will go through a quick overview of what is CDN and how it works. I will also be talking us about some benefits of CDN, and like any other components in the digital delivery, CDNs are critical, and outages or failures can happen at the CDN levels as well. So we will discuss how we can effectively monitor CDNs and some best practices about monitoring CDNs. And finally, also how DevOps engineers can implement a reliable CDN using this monitoring data. So a quick overview about CDN or Content Delivery Network. A CDN is a distributed network of servers that are used to improve last mile connectivity and content delivery for users over the internet. Websites would usually have two types of content. You have the static content and the dynamic content. Static contents are files which remains unchanged for all users for a period of time, such as your style sheets, JavaScripts, and images, while dynamic contents are files which can change for different users, such as like your authentication, your personal feed, or request for your payments and checkouts can be dynamic. So CDNs usually have a large points of presence, and they try to provide a coverage for all major cities across the globe. Traditionally, without a CDN, the site would be hosted on one of the data centers. So let's say in India, and any request has to travel across continents for users who are trying to access the site outside of India. So the farther the geographical distance, the higher would be the latencies and an impact on performance. So let's see how this works with a CDN in place. So let's say we have a user from United States who is trying to access a content in India, and let's say an image. So the request will first be routed to a CDN in United States. The CDN would then request the image from the origin in India. Once the CDN receives the image, it will cache it in its in its cache for a certain period of time as defined by the origin, and then serves it back to the end user. Now there might be a slight overhead for the first request, but moving forward for all the subsequent requests from end users in the similar region will be routed to the same edge server or the group of servers. So now for these requests, the CDN will respond back with the image from its cache, thereby reducing the round trip time it takes to travel across the continents. While this is for static content, CDNs can also optimize your dynamic content by improved peering between the middle mile and the first mile connectivity. So let's break down some benefits of using a CDN. CDNs reduce the last mile congestion and improves the reachability of your site for users. They have wide coverage that provides global reach, and they can handle large amount of unexpected traffic, and it's easier to scale your resources to serve large traffic through CDN. Since CDNs are used to serve cached content from the edge servers and accelerate dynamic content over the internet, they can reduce the time taken to download and accelerate dynamic content over internet. This improves the performance and end user experience, and also threats and attacks are not uncommon for any digital services. So CDNs provide additional security, and provides features like web application firewalls, um, which can improve the security of the site and prevent DDoS attacks. So users can be accessing the site from many devices or different parts of the world. CDNs can help developers offload their efforts in creating content for different consumers, and they can also optimize content by compressing text-based and image files, making JavaScripts asynchronous, minification, and a lot more front-end optimizations. So above all, I think CDNs provide control and flexibility of content delivery for their users. While CDNs are great, robust, but I think they do come with a bit of challenges. And we're going to discuss about why monitoring a CDN is important. So on a high level, CDNs are nothing but a group of servers that are connected together over internet. And like any other services on the internet, CDNs can also be impacted due to failures. So CDN outages are not very common, but when it happens, it can impact not just a single site, but sometimes it can impact all the sites that are served through the CDN. The outages can be regional or global as well. And when there is a widespread CDN outage, then it's probably going to be all over the news, because CDN carry majority of the traffic over internet, and a large network could be impacted. So we've already discussed, we've already seen multiple CDN outages this year from some of the large providers such as Fastly and Akamai that lasted for about an hour. Both CDNs did acknowledge the failures and inform their customers promptly. They tried to restore the services as early as possible, but users were not able to access the site during this time, which impacted a lot of other services and businesses. So some organizations that were monitoring CDN were able to detect and isolate CDN issues faster. This allowed them to take appropriate actions such that their end users were not impacted due to CDN outages. Some common failures in CDN include your DNS and SSL failures, last mile or first mile connectivity failures, performance delays, and cache misses at the edge. So monitoring a CDN becomes important to detect all of these failures and mitigate them as early as possible. Monitoring also helps compare CDN and route traffic accordingly in a multi-CDN environment. So this can help organizations track SLAs provided by a CDN and ensure that you're getting value for investment in your CDNs. Well, so let's discuss about some key recommendations or practices for monitoring your CDN. So in the first step, I'm going to be sharing some services that can be monitored for a CDN. So the first one and the most critical service of a digital delivery is the DNS resolution. DNS, as we all know, resolves domain names like, for example, www.catchpoint.com to its respective IP address, and CDNs rely on DNS resolution process to route users to optimal edge servers. So during a DNS resolution, organizations will be asked to CNAME their domains to another host name provided by the CDN. So this allows CDNs to take control over DNS resolution for that particular domain and then provide the IP address of optimal edge servers for users. So usually with CDNs, it increases the level of resolutions, and we will have more than one group of authoritative name servers. Now, one of those groups could be managed by the organization itself, but the remaining group of authoritative name servers will be managed by the CDNs. So for example, we see here that www.akamai.com has 9 level of resolutions to convert its domain and map the optimal IP address. So DNS resolution usually takes about 50 to 100 milliseconds and can sometimes be overlooked as working perfectly fine. Due to many moving parts in the multi-level resolution, failures and bottlenecks can happen at almost any level or all levels of the DNS resolution. So in this example, we can see performance is inconsistent at level 7, and we see performance going or DNS resolutions taking as high as 3 seconds on level 7. And we also see intermittent failures on level 9, which could be happening due to connectivity issues for one of the name servers. So monitoring all levels of DNS resolution will provide visibility into performance and availability at every level. Even the recent Akamai outage was also impacted due to the DNS resolution process. And I think due to that, users were not able to resolve the domain names to its respective IP addresses and were eventually not able to access the site. So monitoring DNS becomes a critical part of monitoring your CDN. And moving on to CDN mapping dashboard, or what we call the CDN mapping dashboard, it helps you monitor the mapping for your CDN end users to your edge servers. So CDN uses intelligent algorithm to map end users to optimal edge servers that has the least latency. These edge servers are usually in the same geography as the end users to provide better last mile connectivity. Customers usually do not have visibility into user mappings, and sometimes CDNs can be mapping end users suboptimally to edge servers. This can happen if any particular group of edge servers in a region are already serving high amount of traffic. It can also happen if edge servers in the same region have poor peering or last mile connectivity, which will have higher latencies when compared to edge servers outside the region. CDNs can also prioritize the content for premium customers that could impact the non-premium customers or standard customers. And CDNs depend on the location of end users, DNS resolvers, to map them to the optimal edge servers. So if a user overrides his resolver to open resolvers or open DNS or Google DNS, then they might not be mapped to the optimal edge server. So monitoring CDN mapping will provide you visibility into how your CDN is mapping end users across various regions and also latencies associated with them. So on this dashboard, you can see how requests from various cities are mapped to different locations and their respective response times. So if you see that one of the locations is not getting mapped, or request from one of the locations is not being mapped to the optimal edge server or edge location, and if we notice that there's a high response time due to that, then this is something that we can definitely reroute the traffic or maybe talk to your CDN to see how we can optimize this further. So the primary roles of a CDN are to improve last mile connectivity and cache static content. CDNs will cache the content based on TTL or time to live settings defined in their configuration for respective content. But like other cache systems, the most frequently accessed data will remain on top of a CDN cache, while less popular content can be flushed from the CDN cache. Now, a single CDN server can serve content for multiple customers. So if a customer A has more traffic than customer B, then the chances that customer B's content might not be frequently accessed like customer A, and it would be flushed from the CDN cache. This means that CDN servers will have to revalidate the cache with origin and might impact the performance of delivery. So monitoring the CDN cache hit versus miss allows us to validate if CDN is serving content from its cache and also measure the performance when the request being served from cache against revalidated from origin. So in this example, you can see that you can monitor the performance and cache hit ratio in real time. We see that the content was mostly revalidated from the origin, and whenever there was a complete miss, you can see that it took a longer time to receive the response. So when using CDNs, the requests from end users are routed through three fundamental networks, which is the first mile, the last mile, and the middle mile. So the last mile represents the connectivity between the end users and the CDN edge server. The middle mile, which represents the connectivity between one edge server and sometimes another edge server. And finally, the first mile, which represents the connectivity between edge server and the origin server, where the content is hosted. An issue or latency in any of these networks can directly impact performance of the application, especially for dynamic content as it has to be fetched from the origin. Monitoring latency at every layer provides visibility into problems and directions to optimize performance. In this example, we can see that the end user latency is directly impacted due to the edge-to-edge latency. So there might be scope to optimize and improve delivery within the CDN network. And this can be fixed by contacting the CDN support team to see if there's anything that's adding additional latency within the CDN network. I think finally, with respect to monitoring a CDN, if or more often organizations these days are using a multi-CDN setup, so you can easily track performance and availability of each CDN by monitoring them across different regions. So more and more organizations are now adopting to this, and CDNs, multi-CDN strategy is used for various reasons. It is either used to effectively balance a load between different CDNs. It is sometimes used to optimize costs and save with some of the CDNs, and then also to have a better coverage by using multi-CDN strategy. Additional CDNs can also be used as a failover option if your primary CDN has any issues. So monitoring all your CDNs will provide real-time visibility into performance and availability with which we can take appropriate actions. So here in this example, we can see that for this particular test, Cloudflare is not performing as well as the rest of the CDNs. And then we also see an issue with the availability from Asia. So we could probably avoid using Cloudflare for this particular site in Asia, but route traffic through other regions where we're seeing better performance from Cloudflare. Now that we've discussed comprehensively on monitoring a CDN, let us move on to see how DevOps engineers can implement an effective and reliable CDN based on the data. In Catchpoint, we believe there are 4 pillars of monitoring, which are reachability, availability, performance, and reliability. The monitoring practices that we previously discussed can be classified into one of these categories. You will have, you can do trace routes and connection tests to monitor the reachability of your CDN, which will monitor if your CDNs are reachable for users across the globe. Then we have DNS, SSL, and HTTP availability-based tests to monitor the availability of content in the CDN. Latency tests across all networks measures and monitors performance bottlenecks. And finally, CDN mapping and cache hit ratios to monitor reliability of the CDN. So this data can be weighted along with other factors such as cost, security, then geographical locations, and the presence of CDNs to define which CDN has to be given higher priority and which CDN has to be mapped to a particular geographical location or end users. And this can be done by integrating this logic with either your own DNS, or it can be integrated with other managed DNS providers like NS1, Route 53, or DYNE. So the entire process can happen real time. So if there is any issue, all of this process is automated and the end user impact is reduced. So apart from monitoring and routing traffic to optimal CDN, we can also include CDNs as part of continuous integration and deployment process. So this allows developers to deploy and test multiple changes on their CDN staging environment before deploying them on production. It also allows to monitor operation and functionality issues due to changes that can otherwise impact users in production. Most CDNs provide API integrations that allow engineers to configure or update CDN features such as your cache settings, your time to live for the content, image optimizations, and other features. CDNs also provide service workers or edge workers, which are now popular among CDNs. So developers can define their microservices and host them on the edge, and it does not have to travel all the way to the data centers. And the requests for these services do not have to travel all the way to the data centers. So to summarize everything that we've discussed so far, CDNs have proven to accelerate performance and improve digital delivery experience. But by monitoring your own CDN and implementing multi-CDNs based on monitoring data and other factors such as cost, security, and coverage, organizations can achieve better reliability from their CDN setup. So this improves your mean time to detect issues and also improves mean time to resolve them. Above all, this can improve your end user experience, which means improved customer satisfaction and business. Well, that's all I had for this session. I hope this was informational. You can connect to me on LinkedIn and keep in touch for more such information. And thanks to Zelentro for this opportunity, and stay tuned for more sessions.